Welcome, folks. This is the last USU Forestry Extension Learn at Lunch webinar of 2017. So thank you for joining us. I'm really happy to have Larry here today with us, and I'm happy to have all of you guys here today. A couple notes, a couple housekeeping items. We offer ISA or SAF CEUs for attending this webinar, and you should have, if you're in the webinar room, you should have registered for this webinar, and on that registration page, there's a Google form link, and I put that Google form link in the chat pod. That Google form link helps me track who wants SAF or ISA CEUs. So please make sure that you filled out that Google form if you want CEUs for attending today's webinar. And please only fill it out once. That helps me just stay a little more organized. So one more housekeeping item. You will receive an email probably in a couple weeks asking you to fill out a more in-depth survey about our Learn at Lunch webinar series. And so I would ask that you just take 5 to 10 minutes to help us do our job better and understand where we could improve and what we're doing great, and what sort of webinars you'd like to see in 2018. Our webinar schedule is already filling up, so the faster you let me know what sort of topics you want to know about, the more I can find the right speakers to fill those niches. So, all right, without further ado, I'd like to welcome you all here. Welcome Dr. Larry Rupp. Larry Rupp is a professor in the Plant, Soils, and Climate Department at Utah State University. He teaches horticulture, and today we're in the middle of Dead Week, so I really appreciate Larry doing this for us today. He's an extension specialist for landscape horticulture, where he works primarily in the area of landscape water conservation, and specifically on selection and propagation of native plants for use in water conserving landscapes. He's also the director of the Center for Water Efficient Landscaping at Utah State University, and he currently leads the Master's of Professional Studies in Horticulture degree program emphasizing water efficient landscaping. Another note about the water efficient landscaping, they're starting their own webinar series starting in 2018. So at the end of this talk, I'll launch a poll, and if you'd like to be added to that webinar series email list, just click yes, and we will make sure that you get on that list. So I'm going to hand it over to Larry. If you have any questions, please put them in the Q&A pod, and I will do my best to facilitate the Q&A. Thanks, Larry. You're still muted. I don't know.
I don't know who's...
There you go. Got ya.
Okay, can you hear me now?
Yes.
Thank you, Megan. I'm still trying to get over the fact that I was introduced by the Love Shack theme song or whatever. That's not what I was expecting. So let me see if I can figure this out and get us called up here. So does that show the correct page, Megan?
It's probably just transitioning, so give it 1 sec. You click the share screen button?
I'm not sure. Hang on.
So remember, after you click the green share screen button, you're going to get a second window where you have to choose the PowerPoint to actually share it.
Okay, now I'm... Is that doing it?
No.
I'm doing something wrong here.
So you see the Zoom window. Do you see that with the green share screen button?
No, I don't see that.
Okay. I've had this will happen from time to time where you sort of gets lost. Down in your toolbar, do you see the Zoom icon there? You may want to click on that and bring it to the foreground, I think.
Oh, okay. Okay, here we go.
There you go.
Sorry, everybody.
There you go.
Yeah.
How's that go? Earn while we learn.
And then if you enter presentation mode, it will fill up. There you go. Perfect. Okay. You got it.
All right. Thank you.
No problem.
appreciate the opportunity to be here and to share this webinar with you. I know that it's a busy time of year with the holidays coming on, people taking time out of their lunch hour. I hope this is something that'll be of interest to you. It reminds me of a statement I heard once about what Elizabeth Taylor told the last of her 8 husbands. She said, "I won't be keeping you long." So we won't be having you too long here, and we'll let you get back to the other business of your day. But I'm pleased to have the chance to tell you a little bit about what we're doing at Utah State University and selecting and propagating native plants with the ultimate goal of incorporating them as a tool in low water landscaping. As was mentioned, I'm with the Center for Water Efficient Landscaping, and maybe just by way of a little bit of further introduction, our mission at the center is to maintain the quality of life that we get from landscaping while conserving water. We have a number of programs that we use, and you can see some of those listed here. They cover a broad range of research and extension activities. And one of the things that I've worked on in particular is this idea of selecting and propagating native plants for low water landscapes. And one might ask the question, why do we have, why landscaping? Is landscaping worth the water? Is it that big of a deal, or is it just an aesthetic value that is non-essential? Well, I think there's some reasons why it's important. One of those is that in the United States, 81% of the people live in towns of 2,500 or more. And in Utah, 91% of us live in towns of 2,500 people or more. And that may seem a little bit odd, considering if you were listening to the news, we had President Trump out here the other day, and he was weighing in on some national monuments that we have out here. And it sounds like a great deal of Utah's open space, and indeed it is. But most of our population actually lives in urban areas. And what happens in these urban areas is that the constructed landscape becomes the ecosystem for that urban environment. So we feel that the landscape environment is an important one, because the reality is in urban situations, it is the environment. And so maintaining that landscape and using it is important. The question becomes then not so much as to whether or not we ought to have landscapes, but whether or not those landscapes are sustainable. This is a landscape here in Utah, and as you look in the background there, you can see what the native landscape looks like as compared to this botanical garden. And it's a lovely garden, but questions of sustainability we have to ask, how much water is being used? Are we having problems with pesticides or fertilizers? Is it a monoculture situation that we need to worry about? And all of those come to bear as we look at landscapes and what we're doing in the urban environment. So there's a lot of interest in sustainability, but sometimes that sustainability comes with a cost. These are landscapes that I've seen and photographed. They may be very sustainable, the one on the left there with virtually no plant materials in the landscape. Obviously, there's not much use in the way of water or fertilizer or anything like that. And then on the one on the right is one in California using artificial turf. So we can do things to be sustainable, but I would ask it at what cost? And I like this quote from Wallace Stegner. Wallace Stegner was a Western writer, and he grew up on the plains of Saskatchewan on what he described as an alkali flat. And he moved to Montana, and he talks about the first time he walked down the street and saw a lawn, and how he just stooped down and touched it and could not believe that people lived with such grace. And And I feel that way oftentimes about the landscapes that I see, how fortunate we are to have the beauty and the aesthetic values that we get from those landscapes. And I think if we lose these, either because of water conservation or some other means that we feel like we need to eliminate them, then that's to our detriment. So then one of the questions comes, can we use native plants to help us balance this need for sustainability and maintaining quality of life? And it's a question that we're looking at more closely. There aren't very clear-cut answers to these because as we look at natives, it's kind of hard to define what they are. If in Utah we have huge geographical diversity, and when we talk about natives, are the plants that are native to the mountains, are they truly a native to our valley environments where most of the homes are? And so we come into some of these questions, but on balance, I think if we look at native plants and what they're adapted to, they become a tool that we can look at to both achieve sustainability and also make sure we maintain the quality of life that we want. In Utah, as we look at native plants, there's a couple of things that we're after. We hope to take advantage of the fact that they're generally cold tolerant, drought tolerant, and tolerant to our alkaline soils. One of the things we're also interested in is their potential for being produced locally, so that we have plants that are native plants that are grown locally, that are used in local landscapes. It reminds me, I was talking once to Jim Green, a former extension specialist in Oregon, and he asked me, well, we were talking about the fact that Utah uses plants that are primarily grown in other states because it's more efficient for them to grow there. And his question was, why doesn't Utah grow the plants we can't grow in Oregon? And that's always stuck with me. And I've thought about, why don't we grow some of these native plants that may not be able to be grown in other locations? And I think that would be true no matter where you are, that you might have plants that are adapted to your local environment that would be less able to be produced somewhere else. As we look at native plants, one of the things that kind of goes along with that is the idea of, should we be looking at strictly just native populations, or can we be looking at cultivars of some of these native plants? And this picture illustrates a Juniperus scopularum, Rocky Mountain juniper, and on the left are native plants, and on the right is one called woodward that has a very narrow columnar shape. And some of these cultivar type native plants also, I think, hold great promise, because they have the potential of giving us the superior traits that a native plant would have through their adaptation, but also the traits that we might be looking for. In this case, a columnar plant that might work as a screen without taking up a lot of space in the landscape. So we're interested in not only natives, but selected natives that might have specific advantage for us. One of the challenges, though, becomes that a plant just being native is not enough. As we look at the industry as a whole, there are people that are very interested in having landscapes that are entirely native, and that's great. But industry-wide, I think people are more interested in a variety of things that are going to work for them. If we look at the nursery industry, they require some specific things from the plants that they're growing. They need to have predictable performance. They need to be uniform in their performance in both production and the landscape. They need to be able to propagate them, and they need to be marketable. Other things that they also would appreciate and look for are plant hardiness, pest resistance, efficiencies and tolerances. So we've got to go beyond native to find plants that allow the industry to get out and market and sell those plants. And so this brings us to the primary project that we've been working with here in Utah, and that is selecting and propagating one of our native plants, which is the bigtooth maple. Bigtooth maple is actually considered now a subspecies of the eastern sugar maple. We find it here mostly in our transition zone between the valleys and the mountains. You can see in the background of the picture the red color in the fall that we get from the maples, and it's pretty common throughout the state of Utah and throughout much of the Intermountain area, and indeed through much of the Southwest. It's an interesting plant in that it's easy to grow from seed. Obviously, it's native. It's an attractive tree, and it's adapted to much of Utah. But it never really has captured the public's imagination. And there's a couple of reasons for that. One is that it grows very slowly, and so it's been difficult to produce it. And also, we've only recently have we had clonal selections or cultivars that we can offer to the industry, and so there's been a fair amount of variability with it. So our interest has been, can we find superior selections of this bigtooth maple, figure out how to propagate them, get them grown and produced in the industry, and then utilized more in our landscapes. The first question for us then has become, how do we select these trees? In Utah, the bigtooth maple is very diverse. We have anything from trees that are approaching 60 feet in height with a very excurrent type growth habit, a single leader, to very shrubby types. Their growth and performance is affected a lot by the environment that they're in. We also get a great deal of diversity in the fall color that we would see, anything from very light yellow pastels to deep maroon reds and virtually everything in between. So having some kind of a clonal selection would permit us to better market the plant, to more easily produce it, and also to give landscape architects and others an idea as to what kind of plant it is that they're going to be growing. So how do we select them? One of the ways that we've been doing it is by word of mouth, and it's enabled us to find pretty unique trees such as this one, which is in the mouth of Parowan Canyon, that's down in the down near Cedar City in Utah, or if you've heard of the big fire we had out there this year up by Bryan Head Ski Resort. This is in that area. And initially we were selecting trees primarily for their fall color. So we were looking for red trees, and this is a good example of one that we found. This is another one that we found over in Box Elder County, and you can see it on the left. It's one that retains its leaves very well into the fall and has a deep maroon color and retains that color. It's the same color, appears every year, and it retains that color and shows it in the landscape as well. Another thing that we've done is used aerial imagery when we were looking for red color. That's something we could target, and we happened to come across some Google Earth images that were taken during peak fall color, and so we were able to select some trees from that. We have also been able to go up and do some aerial photography, and there's different ways of doing that. I have to admit that this little plane you're seeing here, someone helped me set up an opportunity to go do some aerial photographs, and I didn't realize we were going to go up in a 1952 Piper Cub with fabric wings. So that was quite an experience, but one of the fun things that kind of comes along with this job on occasion. And so we've been able to go up and do some aerial photography, and there's some really neat things that we can do. And I'm going to explain a little bit of how we do that for a couple of reasons. One is that we can always use good ideas on where new plants are. And so if any of you have a chance to look for plants or If you find native plants in your area that have unique characteristics or look like they'd be great in the landscape, I'd encourage you to pursue them, to look at propagating them. At least, if nothing else, get your GPS out or your cell phone and get a latitude, longitude on them so that you can forward the information on to someone else, a nurseryman or someone at the university that might be interested. This is a tree that we found through Google Earth that caught our attention. It was up in a canyon called Smithfield Canyon here in Utah, and we were able to see it as we did the overflight. And the interesting thing with the technology we have now is that at the time these pictures were taken, we used a camera and a GPS unit to track the time, and then a software called GeoSetter that allowed us to link the images that we took with our location so that we could go back and find it. We found out pretty quick that if you just fly over a mountain and take a picture and then try and find where that picture was taken, it becomes very difficult. Nowadays, it's even easier with many cameras having GPS units built into them, and so it's much easier to take a picture and find out where it is. With this GeoTracker software, we were able to map out where we flew the airplane and the images that we took, and then we could put those into Google Earth, as you can see here, and figure out where we are and where the image is being taken so that we can get on the ground and find those trees. This is the tree that we located from the air. We were able to, once we were able to find it on the ground, then we could go up at the peak fall color and take some pictures of it, look at the tree more closely, see if it had the kind of characteristics that we wanted in addition to fall colors, such as minimum of disease or insect problems and things like that. Sometimes it becomes a real challenge in our situation to find the trees on the ground. This would be a good example. We were doing some aerial overflights and we noticed this tree that had a nice pyramidal shape and a good red fall color. And we had a picture of it, but the trick was how to find it. And we knew from our GPS the proximate area where the image was taken, and this is kind of a low-tech way of doing it, but we were able to manually compare the two pictures that we had to try and figure out where this tree is. So on the upper picture with the triangle, that's the tree we were looking for. We could see some local characteristics that we could use for landmarks. So on the left, there's that wide area. On the right is a cultivated field, and then another area there in the center where we have some more kind of a stream bed. And by doing that, we were able to find eventually the location of the tree, and then we can zoom in on Google Earth and find the exact latitude and longitude of that tree using Google Earth, and then using a handheld GPS and the photographs, we can get out on the ground and actually find the tree. This is a real, I'm trying to figure out how to say this. This technology has, I think, really revolutionized our ability to find plants like this, that we can actually go out and take a picture and then figure out exactly where that is and home in on it with a GPS unit is allowing us to review and look at a lot more plants than we could have otherwise. Once we have located the trees that we're interested in, the next step for us has been to try and figure out how to propagate those trees. And with bigtooth maple, as I mentioned, it's fairly easy to propagate, and we can go out in the fall of the year. About every 2 or 3 years, it produces a good seed crop. We can stratify the seed by putting it in a Ziploc bag with some moist vermiculite, and basically all we do is put it in the bag, put it in a cooler at about 34 to 38 degrees Fahrenheit, And then as we watch it over time, we find that the seed will germinate even in the refrigerator, and then we can simply transplant it to tubulings or other growing methods like you see here on the lower left. And so that's easy to do. Again, the problem with it is the genetic diversity of these plants is great. It's tremendous, and it makes it difficult for us or for the industry to market it as anything more than a native plant with native characteristics. And so we are also interested again in getting to be able to propagate it as a clone. And so rather than just collecting seed, what we did in this case, we would select our plant and then go up at the right time of year and collect budwood from the plants in the wild, bring them down into a nursery environment. In our case, a nursery that we had with some bigtooth maple rootstocks, and bud onto those rootstocks in the hope of developing a clonal population that we could use to produce the plant. Budding these maples had its challenges. I think the biggest problem that we have is that if you look at a nursery environment, they do everything they can to ensure that when they're doing grafting and budding that it's successful. The scion wood is produced at its optimum. The rootstocks are at their optimum. They do everything at the best time of year, and as a result, they have great success. We found that it's different when we go out in the wild and collect budwood from trees that are growing in an area where they haven't been maintained or managed. They may be under a great deal of stress, and so we get variability in our ability to get those buds to take. And as you see here, you can see what a successful bud would look like on the left. On the right, we would have a lot of buds that the bud shield would take okay, but the bud itself would abort, and we weren't able to get the plant to grow. But ideally, we get what happens there in the middle where the bud takes. We're using chip buds, and they grow. And once we've got them in the nursery, then we can start to manipulate them and work with them, and things become much easier. We did a little bit of research on when the best time of year was. We found that at least for northern Utah, if we come in around the end of about the middle of July and into about the middle of August, we can get pretty good budding success with those plants. And it allows us to capture this wild germplasm and bring it in and establish it in a nursery environment where we're able to manipulate and grow it. Once we had them growing in the nursery, our next step, what we wanted to do was to try and see if we could grow these plants on their own root, on their own roots. In Utah, we don't have much of a nursery industry. We don't have a lot that's going on with things like budding and grafting, and so we thought, well, the easiest way to produce these is going to be if we can root them as a cutting and grow them out that way. Unfortunately, they're fairly difficult to root. You can see the one on the left with no roots as compared to the one on the right that's had a reasonable rooting performance. As we tried different methods of trying to root these plants, one of the things we thought we would try is to build on some work that Brian Maynard and Nina Bassick did back in New York on etiolating these woody cuttings with the idea of improving their ability to root as a rooted cutting. And what we came up with was a little technique where we would prune the trees in the winter and then put a black velour bag over the end of the stub with the idea that we would have the buds break and grow out through that bag, and then we would get etiolated shoot growth that we could hopefully find easier to root. And you can see the cutting there in the middle, or the shoot, how creamy yellow color and the yellow leaves, that's what they would appear like inside the bag. Meanwhile, as the shoot tip grows out of the bag, it's in full sun and takes on its normal characteristics. So that we found it was the cuttings overall were hardy and well adapted, but the base of the cutting was etiolated. That etiolation means that the wood is a little bit softer. It's a little bit more susceptible to the influence of rooting hormones. And so we tested this out using standard production systems where we treated them with an auxin, put them on a mist bench with bottom heat, and we did indeed find that the etiolated plants rooted much better than the non-etiolated, with the etiolated being there on the top of your screen. If we put that in a graphical form, this is the percentage of rooted cuttings. We found that etiolated shoots rooted significantly better than the non-etiolated, and with a number of different varieties. These are 6 different accessions of trees that we looked at, and they all had a greater percentage of rooting, and they all had significantly more roots per cutting. So we were happy with that. And that gave us plants that we could grow on their own roots. Again, though, we found ourselves in the situation where, well, we've got these rooted cuttings, but we've got to etiolate them. You got to have the stock plants. Maybe there might be an easier way to grow them on their own roots. And so we thought we would try a couple of other different models. And here we tried 2 different things. The first one is to work with J. Frank Schmidt Nursery in Oregon. They were great to work with us on propagating it using their standard production system, where we would send them budwood and they would graft it onto sugar maple rootstocks, grow it out, and then they would ship the plants out as a bare root whip, which we potted up for our evaluations here in the state. So this is kind of the standard production system. We were also interested in seeing if we could use an old but well-proven propagation system of layering. If you look at a bigtooth maple, oftentimes we see trees like the one here on your left that have multiple trunks. And those multiple trunks are oftentimes caused by layering. If you look at the plant on the right, there's a branch that's growing horizontally there, and where it comes down and touches the ground, those will actually root and layer in that spot, and then we eventually get a new tree that is attached to the parent tree but is growing up from that spot. So we felt like there was pretty good potential for rooting of layers, and we proposed this model where we find the wild tree, bud it, get it in the nursery, use the etiolation to get it on its own roots, grow it out, and then plant it into a stooling bed where we can use mound layering to hopefully root the plant. And so with some of our selections, we established a stooling bed, as you can see here, with irrigation system and weed barrier between the rows. We would come in and grow the plants out, apply a girdle to the base of the stems, and then an application of a rooting hormone, and then would mound up around the bases of those plants with conifer wood shavings, keep it moist during the summer, and then in the fall of the year, if everything worked, we were able to get rooting such as you can see here. So we would get roots forming on the bases of the shoots. Those could then be snapped off at the girdle or cut off with shears. And if everything worked right, if everything worked perfect, we got a plant that looked like the one on the right there, the bare root maple with that very extensive root system. The reality is that we've had kind of variable success with this. We have some cuttings that have worked very well. with a lot of roots, and others that either don't root at all or have very few roots. And we see variation within the as a result, we've come up with another model for trying to produce these maples. And it's basically, we find the wild tree, get some buds from it, establish it in a nursery. Using the etiolation method, we root some cuttings so we have the plant on its own roots. We then grow that plant out, and when it's up to size, we plant it into a stooling bed, such as we showed, prepared or stooling bed, and then we can grow it as a mound layer, and with the idea of rooting the cuttings in the mound layer. So to do that, we first of all established a stooling bed down at the USU Botanical Center in Kaysville, and you can see we've got rows of in this case, these are clones of the maples, and with the weed barrier in between them. And we grew the trees out, and then when we want to root them, the way we would do that is put a girdle on the stems and then treat above the girdle with a rooting hormone, and then cover with the conifer wood shavings, as you can see here. And then we would use our sprinkler system to keep it moist. And in the fall of the year, we can go in after the tree is dormant, remove the mulch, and hopefully, if we do everything right, the shoots all have roots that have developed around their base, and we can snap those off at the girdle or cut them off with a pair of pruning shears. And at the very best, they look like the slide on the right there, where you can see the number of roots on that cutting. Unfortunately, we're seeing a fair amount of variability both within the cuttings or the shoots on a given year and also between years. So sometimes we have extensive root formation, other times little or no root formation, and we're trying to work out some of the uniformity issues on this before we actually get around to publishing this work. We'd like to have this problem solved. The other part that is sort of in the equation is the evaluation of the performance of the trees. And we've done this at a couple of different stages. On the far left there, you can see our selection. It's 1005. This is up in Oregon in the J. Frank Schmidt's nursery. And the two on the right are trees that have been planted out in that we can take a look at them. There's been some interesting things that we've learned from this, more than just whether or not these trees are going to perform. One has to do with the number of pest problems and things that we might see in a nursery situation. If you look at bigtooth maple in the wild, one of the things it's susceptible to is a number of different leaf diseases: ink spot, anthracnose, and powdery mildew. It also is susceptible to a borer that can get into the stem and kill the shoot tips, and it's also susceptible to cicadas that can come in and by their ovipositing can kill branches. As we brought bigtooth maple into a nursery environment, we've had the standard disease problems with the leaves, but we've also found that we get problems in propagation, phytophthora or other root rot type diseases on the cuttings, botrytis on the leaves. We've seen insect problems, aphids, and I've got to admit, aphids also occur in the wild, so aphids are everywhere, but we see some thrips damage in the nursery that typically I've never seen in the wild. More importantly, we've seen some real problems with our stems, the trunks of the tree. And what we're seeing, I believe, is a problem with southwest winter injury coupled with, in this case, flathead borers. And we're not quite sure why the borers attacked the maples the way they did. I'm assuming they were under stress. They were in a an area that was sort of semi-developed and maybe they weren't getting as much irrigation as they should have. Another thing that we have found is that deer just love to rub their antlers on them, so we've lost trees due to deer damage. And then just in general, we tend to see problems with healing up at the base and what I assume is winter injury or southwest winter injury. So we're having some challenges evaluating these trees, but we are continuing to look at them and trying to determine how they will perform in the landscape. Right now, there are 2 commercially available bigtooth maples. One is Mesa Glow. It was one that was developed by Ralston St. Hilaire and his group at New Mexico State University. Very nice tree, has good fall color, and has good, strong vigor. J. Frank Schmidt Nursery has introduced one called Rocky Mountain Glow. It's been around for several years, and it is available. And we're working on this little 1005 and hoping to release it in the sometime in the future. We're excited about it for a couple of reasons. Probably the biggest of which is that it has a really tight crown, and we think that it will do well in a small suburban landscape type setting. So if you've got a small landscape that you really can't afford to have a big tree there because of surrounding buildings and whatever, that this tree might be an option to try. There's some other native trees in Utah that we're also interested in looking at besides the bigtooth maple. This is a picture I took recently on Antelope Island, an island that we have out in the middle of our Great Salt Lake. And this tree, is, as near as I could tell from the distance I'm from it, is a netleaf hackberry, and showing an example of a tree that can thrive in a pretty harsh environment. So we've got some other trees that we're looking at and hope to be looking at more closely. One of these is Gamble Oak, or Quercus gambellii. Gamble Oak is native to the Southwest and the Intermountain area. It's in the white oak family. It's easy to propagate from seed. It has a number of advantages in landscape situations. It's a tough tree. The biggest complaint I hear about it is that people tend not to like it suckering after they've had it for a while. And so we're interested in, we find clones that are less prone to sucker, and can we propagate those in the landscape along with other desirable characteristics. One of the things that's really led us to take a look at this tree is a collection of oak hybrids at the University of Utah called the Cottam Oaks. They were hybridized by Walter Cottam over 50 years ago. And some of them are pretty spectacular trees. This is a cross between Gamble Oak and Quercus macrocarpa. And in the process of a construction project, they were losing this tree, and they asked us if we would come and see if we could try and propagate it. And so we were able to collect some budwood, and we found that at least with this scion, grafting it onto a Gamble Oak rootstock, it did quite well. If you look at the picture on the right, you can see that the scion is well established. The bud has healed. It's showing good vigor. And our next step with this plant is to see if we can bend those shoots over and get them down under our conifer wood shavings, and see if we can layer it and get it going on its own roots. And we think it might have some potential doing it that way, and we're kind of excited about trying it. Another one of the reasons that makes us think that we can do that is that we indeed have propagated some Gamble Oak seedlings. They're not clones, but some seedlings we've been able to propagate by layering. Here you can see a layer on the left along with the zip tie that was used to girdle it. And it's kind of interesting, if you look at the graph on the right, it shows the percentage of rooting that we've gotten from our treated shoots on these oak layers over the course of 4 years. And every year we tend to get a few more, a higher percentage of rooting occurring. So we're not out of the woods yet. We're still seeing, again, problems with variability, but we're thinking this might indeed be a way where we can propagate Gamble oak or Gamble oak hybrid clones. One of the other clones we're particularly interested in is this one. This is a hybrid between Gamble oak and shrub live oak. Shrub live oak, or Quercus turbinella, is native to southern Utah. It has a very small holly-like leaf and it's evergreen. But it does hybridize with the Gamble oak, and those hybrids are hardy in northern Utah. And we think that this one has merit for use in the landscape as a small oak that we could grow. We've tried propagating it with chip buds, as we did with the Macrocarpa hybrid, and we found a couple of things. One, that the buds have a fairly low success rate, and when they do take, we find that we get growth rates such as you can see here, but then as the heat of the summer comes along, they'll just collapse. And what we believe we're seeing is that the vascular tissue is not developing as rapidly as the rest of the stem, and perhaps the scion is demanding water faster than the rootstock can get to it through that graft union, and so it fails. So we've been trying to see if we can come up with a better way of grafting them. On the advice of Guy Meekum from J. Frank Schmidt Nursery, we tried last year a hot tube grafting using another Gamble hybrid on Quercus montana rootstock. And you can see the idea here is that this is actually inside of, if you can picture it, this illustration is inside of a walk-in cooler. And there's a plastic tub with some moist sawdust and a tube with a heating element in it with slots cut for the graft union. We lay the graft union inside the tube, close it off with some styrofoam insulation, and then put more moist sawdust over the top of it, and then just leave it in the cooler. The idea is that the shoot, the scion, and the root system stay dormant because it's cold, but the graft union heals as a result of the heat that's put on that graft union. We found that indeed this method works, and if you look at the slide on the left, that's scion that's broke bud and growing. You can see the grafting rubber band that's still attached to it, but it's not fail proof. If you look at the one on the right, we found also with these that some of them will collapse as we get later on in the season. And this collapse is an interesting thing. If anybody has any ideas, I'd be really interested, because they don't wilt or anything. We come in one day and they're fine, and then we come back the next day and bam, the shoot is dead. But pretty sure it has something to do with that graft union. But we're hoping that we can maybe leave it in the hot tube system for a little longer to ensure that the graft union is healing better, or slow down the growth of the scion so that the graft union has more time to catch up to it. But one of the projects we're kind of excited about and looking forward to working on. As we look at this concept of taking native plants and turning them into cultivars and then growing them as monocultures, you have to wonder if we're trying to get a monoculture of native plants that's resistant to problems but still has all the inherent difficulties of a monoculture. And that's a concern. If it's not going to do us any good if everybody in Utah plants the exact same clone of a maple tree, and then we get some pest from China that comes in and wipes out all those maples, like, say, for instance, we're seeing with green ash in some parts of the country. So I think one of the things we need to do is, while we're looking at native species, we also need to be looking at a number of different varieties. And that would help to give us the diversity that we need to ensure that we don't have so many of these monoculture problems. And I think that as we look at landscapes in general, if we have a landscape of mixed species and mixed native cultivars, they can be attractive, they can be diverse, and they can also be sustainable. And hopefully, as we learn more about them, we can create landscapes that have the best of all worlds and allow us to conserve water.